Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. In today's video, we're gonna do Theorem 2 under circle theorems. Now, Theorem 2 states that the angle, the angle which an arc of a circle subtends at the center, very important, subtends at the center of a circle is twice the angle the same arc subtends at the circumference. Now, this is an arc. This portion is an arc. Portion AC is an arc. If I were to take this portion, maybe portion BC, it is also an arc. Now, a circumference, it is any point on the circle, or like this. Any point that touches the circle here, we call it a circumference. Even if we were to have an angle here, this angle here, it is at the circumference. I hope that's clear. What's the circumference? Remember the center, it is where here where you have a dot, and normally they call it O. This is your center. Again, so now when you go back to theorem 2, it says the angle which an arc that we are talking about, it is arc AC in this case. The angle which an arc of a circle subtends at the center. This arc subtends this angle here. This arc subtends an angle at O. It subtends an angle at O. It comes from both AC again. So it subtends this angle. Now we are told that angle it subtends at the center, it is twice an angle it subtends at the circumference. Still, check this same AC, it is subtending an angle at B. I repeat, let me start again. This arc subtended an angle at center O. Again, this angle. But the very same arc AC, it is subtending an angle at the circumference B. So now we are told that if that's the case, this angle first subtended here, it is twice this angle here. If this angle is x at the circumference B, it means this angle it is 2x. Now, if this angle here it is 40 degrees, it means this angle here it is how much? 20. You get the point that I'm trying to explain here. Yes, I hope it's clear. I hope it's clear. This angle subtended by this arc at the center, it is twice the angle the same arc subtends at the circumference. This one is very straightforward in terms of understanding. Now the reasoning, when you reason, what you're gonna write, you're gonna say angle, this is angle, not L. Let me do this. Angle at center, it is equal to twice angle at circumference. You are done. You are done. Or you can write it in full, circumference. But I prefer saying angle at center. This is your reasoning. Remember, in Euclidean geometry, you have to do statement and reason. Angle at center, it is equal to twice angle at the circumference. You can just say circ like this. Angle at center is twice angle at the circumference. Now, you are also required to prove this theorem. But before that, let's do some few of these theorem and try to make sense of it. Now, if we have something like this, if this is my arc, let me call it A and B. If this is my arc and this is my center O, if this arc, let me show you. let me do this. If this arc subtends an angle at the center like this, again, this arc has subtended an angle at the center, but I go back and the very same arc subtends an angle at the circumference like this maybe. So this is also applicable because per definition, or per definition of this theorem, it says the angle subtended at the center, which is this one in this case, it is twice the angle subtended at the circumference. It is also applicable in this case. As long you can follow the lead of this arc AB, I'm doing in black here, it subtends an angle at the center first, and then comes back and subtends an angle where somewhere at the circumference. Remember I said the circumference, it is any point on this portion of the circle. Again, even if I were to do like this maybe and say it subtends an angle here, and say it subtends an angle here. I'm not sure how to do this, but let me see if this is correct. Oops. All right. I can get that one right. All right, like this. This arc, this point here, A, B, first subtended an angle at the center. Let me use my a different color. This AC started by subtending an angle at the center, which is O, this angle, and then came back and subtended and another angle, but in this case, remember, look, I'm moving from A here and from B to the circumference, this angle. And we know as per definitions, it says that this angle here at the center, it is twice this angle here. This is also applicable. Last example that is really asked but can catch some student, it is when we have this. Let's say we have our arc here. A, B, and any point on the circumference. Let's say this is C. Let's say I have this. Here, and why is this here? It should be on the circumference. And let's go to let's say this is our center O. This is our center O. From my circumference to here, from my circumference to the center again. Let's say I have this part in this case. If I have this, I'm gonna say this is my arc. Again, please take note. AB is my arc. Again, it subtends an angle at the circumference. Which angle am I talking about? This one or this one? That is the question. This one or this one? Before you do that, let's check it subtends an angle at which circumference first. Here, this one comes here at the circumference, and this one comes here at the circumference. This is the angle again. So when we use this theorem, one angle should be inside, other angle should be outside. I believe you are following. I will repeat my statement. If this angle here, it is here on the inner part, let's say this is X, it means my angle subtended by the same arc AB on the center should be an outside angle. I hope you are following, and I believe you are following. This one is the one that's tricky. They rarely assess it, but they do. This is my circumference. This is my center. If I had something like this, maybe let me bring back this x. If I had something like this, um, maybe I had mm, no. Okay, it is like this. This one, it is always like this. There is no way this one will be the center like this. If you want to say this is twice, sorry about that. If you want to say this is twice, then it means it should subtend and sorry, I don't know why this pen is doing this. We should subtend an angle somewhere there. You see? You remember this part. Let me try to erase this so that you can see what I'm trying to talk about. If this is twice, if we are talking about this one in this case, let me do this. If you are now talking about this one, it means the angle that should be subtended at the circumference should be this one, because this one is the outer. It means the angle should be the inner one. I hope you are following. I will repeat this for the last time. I will repeat this for the last time. The angle here, reverse. The angle here, it is the inner angle. It means the angle subtended on the center should be the outer circle. Again, but if I change my scenario and do this and say this is my angle, now it is outside. Again, rather, yeah, outside. Therefore, it means my angle should be somewhere there inside. We did this. This is what I'm trying to explain. If this is twice, it is outside of this triangle or whatever the shape is. This one, it is inside. Again, we see this one, it is outside of the shape of this triangle. This one, it is inside. Again, yes, that is what I was trying to explain there. But now, the part that's important is now the proving part. You are required to prove this theorem. You are required to prove that this angle at the center here, it is twice this angle here. Let's try to do that. Let's try to do that. Let's just write out this part. Given, we are given, nope, we are given center O. We are given point, these are the points on the circumference ABC. Now we are required to prove that they normally say required to prove that A angle OC, it is equal to twice A angle BC. I will repeat the statement. You are required to prove that A angle OC. Sometimes people get confused with this naming A angle OC. This angle that has a cap in the middle is the one that we are referring to. But how we are gonna go about that one? A angle OC. The angle, the letter or the whatever in the middle is the one that we are looking for. Alright? So remember, we cannot just say O, because this is also O. Again, this is also O, a full. So we have to name specifically which one. So you can say this is A1, A2, and whatever, but it's fine. We will see as I do it. We are required to prove that this angle here, it is young, it is twice the angle at the circumference, as per definition. Now let's try to prove that. Remember, I always say this. When you are required to prove in a circle theorem, the first thing that you are supposed to do, it is constructing a line. But in this case, you're going to construct a line from the circumference to the center, passing the center, and maybe name this M. or whatever that you want to name it, or even if you do not name it, in this case, it does not matter. Then call this 1, 2, and call this 1 and 2. This is for you to, so that your proving can be easier. You'll see what I'm trying to say when I say my proving to be easier. The first thing that I'm gonna do, the first thing that I'm gonna do, I'm gonna say now, all right, I have joined my BO, again, and whatever the letter here, M. I have constructed that again. Now I will say, all right, one should take note that this is the radius and this is the radius. So remember, if the radius are equal, they subtend the same angle, or rather the angles subtended by those radius are equal. What do I mean? I mean this. Maybe a different color will do. Let's use this one. I'm saying if BO and OA are the radii, both radius, it means the angle subtended by them are equal. This angle and this angle is equal. Remember this triangle, you call it a what? Is it a what? An isosceles triangle? That's like this. If this side and this side are equal, it means the angle subtended by those sides are equal. This is what I'm trying to explain here. This is what I'm trying to explain here. All right. The first thing that I will say, let me remove this. Let me remove this. I will start by saying OB. I'm looking at this triangle. All right. Let me just mention this. In triangle OBA, what's happening in that triangle? I'll say now OB, it is equal to OA. Y radii, or equal radii. Okay. Now, if those two are the equal radii, it means now what? It means this angle B1 and angle A are equal. It means B1, it is equal to angle A. You do not need to say angle A1 or what. I repeat, B1, it is equal to angle A. Why are we saying that? We are going to say angles opposite equal sides. This is the reason we've been using from grade 10. Angles opposite equal sides. Now, if they are equal, I can say maybe this is x, this is also x. But if I see very well here from, let me use my highlighter, A, B, O, M. It is an extended triangle. I'll construct it for you. I'll try to construct it for you so that you can see. A, B, O to M. A, B, this is B1, O, this is O1, and M. This is an extended triangle. Remember, on an extended triangle, it says this angle O1. Angle O1, it is equal to the what? These angles that are adjacent to the sides. Now, you should remember this one from grade 10 work. This angle O2 is going to be the sum of these angles, angle B1 and angle A. So what I'm trying to say is that angle O1 is going to be 2x. Again, this is what I'm trying to say. Angle B1 is going to be twice this, or rather is going to be the sum of angle A plus angle B1. That's what we are required to remember. So we are going to say now angle O1, it is equal to, now I can say angle O1 it is twice angle B1. Why? Because angle B1 it is also the same as angle A. So instead of saying it is equal to angle B1 plus angle A1, I know angle A1 or rather not angle A1. Angle A, I know angle A it is the same as angle B1. So this is the same as saying it is twice angle B1. Why are we saying that this is exterior angle of a triangle? Exterior angle of a triangle. This is the most important part. O1 is twice B1. This one there's no need to write it. Alright? Then let's move on to what now? To the other side. I'm done saying this they are equal and now saying this it is twice that angle. Let's move on to the other triangle. Let's say in triangle in triangle OBC. In triangle OBC. Let's see what's happening in that triangle. Triangle OBC. Let me remove this mess. These provings are very important. They will appear on your June exam. One of the ones that I'm gonna do until I end this topic of Euclidean geometry. Now, when we focus on this side, we see we have a triangle here. This is our triangle that we're gonna be focusing on. Then I can extend it also. Similarly, I can see that BO it is equal to OC. Why? Line from the center to the circumference, that is a radius. Line from the center to the circumference, that is a radius. So it means BO it is equal to OC. Why am I saying that? Because equal radii. Equal radii. I am saying I've forgotten what I was saying. OB is equal to OC. OB it is equal to OC. Why? They are radii. Okay? Then now, if these two are radii, it means the angle that they make there, this one, they are equal. Why? This angle here, if this is equal to this, and this is my complete triangle, it means this angle here, these two angles here, they are equal. This is what I'm trying to explain here. Okay? Therefore, it means angle B2. It means angle B2 here, it is equal to angle C. Angle B2 it is equal to angle C. Why? Angles opposite equal what? Equal sides. Therefore, I also have what? A triangle that's extended. In this case, you can see here I have an extended what? This is my M, this is my C, this is my B2, this is my what? This is my O. So I know this angle O2 here. This angle O2 here. Oh, sorry. Angle O2 here. It's gonna be what? This angle plus this angle. It's gonna be B2 plus BC. B2 plus C. So it means if this is Y and this is Y, this is gonna be 2Y. So we will just say angle O2 is equal to 2B2. It is twice B2. Kappa, I can say angle O2 it is equal to angle B2 plus angle C. But I know this angle here it is equal to B2. So it is the same as saying B2 plus B2, which is 2 angle B2. Again, why? This is called exterior angle of a triangle. The important part is this one. Now, let's see. We know that angle O1, which is our center, plus angle O2, We just proved that, or rather, we did not prove, but we just, if I were to say angle O1 plus angle O2, it is equal to how much? Hmm? It is equal to how much? Remember, I said angle O1, it is twice angle B1. That's what I said here. Angle O1 here, it is twice angle B1. That's what the statement and the reasoning we did there. Again, now what is angle O2? Angle O2, we just said it is twice angle B2. Again, now if I were to factor out here, if this is angle, sorry, this is angle O1 plus angle O2, I can factor out here twice what? Or rather, sorry, my highest common factor is 2, B1, B2. But now, if I were to check what is O1 plus O2, O1 plus O2 are these angles. O1 plus O2. So it means it is this angle AOC because it is both of these angles combined. So O1 plus O2, it is what? AOC. This is the same as saying A angle OC. The angle is O. It is equal to twice what? Let's go back and see B1 plus B2 give us what? B1, it's here plus B2 here. When we combine this angle here, it gives us what? AO, rather AB, ABC. So I can say now, we can come here and say twice what is B1 plus B2? B1 plus B2, it is A angle BC. This is what was required from us to prove that angle AOC, it is twice angle ABC. This is what we're required to prove. Angle AOC, it is twice angle ABC. That's all for today. Theorem 2, and also it's proving. So I hope you understood what I just explained here. And if you did, please give our video a thumbs up and kindly subscribe if you haven't done so. And you can also share this video to your friends if it was helpful for you, so that Ilbona, they can be helped. So thank you very much, folks, for today. Until we meet again on our third video uh, on Theorem 3. Thank you very much.